Geometrical interpretation of secant method or regular falsy method. There is slight difference between secant method and regular falsy method. But here in secant method we have first initial approximations are what? Xk minus 1 xk. We have xk minus 1 xk as initial approximations. Then corresponding to the equation f of x equal to 0, the curve is y equal to f of x, right? Okay, corresponding to the equation f of x equal to 0, the curve is represented by y equal to f of x, means y equal to 0. Now at xk minus 1, the point or the value at xk minus 1, the value on the curve is fk minus 1. Similarly, at xk, the value on the curve is fk. Therefore, the points on the curve y equal to f of x are, one point is xk minus 1 fk and another point is xk fk. Now join these two points by a line segment, straight line. Line segment means straight line segment, or it is also named as chord. It's line segment chord. Then this line intersect x-axis at the next approximate root. Okay, let me show this one graphically. The graphical representation is, see, this is the graph, x-axis, and this is y-axis. Okay, let me take the curve like this. Okay, take curve like this. Take this point x0, okay, and take this point x1. At x0, the point on the curve is this. The curve is like this. This is the point on the curve, and at x1, this is the point on the curve, and this is exact root xi. And if I join this point and this point by a straight line, roughly I'm drawing the straight line, it comes like this. Then this is the next approximate root x2. This is secant method. Secant method. Now if after getting I can say like this: if the approximations, if the approximations, if the approximations are such that if the approximations are such that, how to take approximations? The condition is fk into fk minus 1 less than 0. Then secant method is known as regular falsy method. Secant method is known as regular falsy method. Okay, let me explain this clearly. Now, what is the thing here? The condition is what? If I mention this condition, f of xk into f of xk minus 1 less than 0, intermediate value theorem. If I apply intermediate value theorem at each iteration in secant method, then that method is known as regular falsy method. Let me express this one graphically. See, I'm taking regular falsy method graph here, x-axis, and this is y-axis. Okay, and this is the curve. And what is the thing here? If I consider x0 here, let me take f of x0 is positive. This is the point on the curve. And let me consider x1 here. This is the point on the curve. Okay, this is the point x0 comma f0, and this is the point x1 comma f1. This is the point, and this is the point. Now this is exact root psi. Now if I join these 2 points by a straight line, this is a straight line, it intersects at the point x2 here. Okay, this is the next approximate root x2. But see, in secant method, after getting x2, the next approximate root lies between x1 and x2 in secant method. But here I have to calculate f of x2 value in regular falsy method. Once again, join these 2 points x0 f1, x1 f1, get the straight line, it intersects at the point x2. But in secant in regular falsy method, after getting x2, find f of x2 to decide this condition. To find f of x2, for example, if f of x2 is negative means lies in 4th quadrant. This is the next point. Now this is negative, which is positive? F of f0 is positive, and this point is what? x2 comma f2. f2 is negative, f1 f0 is this one positive, f2 is negative. Therefore f0 positive, f2 negative. So next root lies between what? x0 and x2. Now I have to join which points? Now these 2 points I have to join by a straight line, and this intersect at the point x3 here. Now if f of x3 is negative, for example, just to explain the concept, I'm telling this is negative means lies in the 4th quadrant. Then again, this is this is x3 comma f3. f3 is negative, and which is positive? f0 is positive. Therefore next root lies between x0 and x3, and join these 2 points to get a straight line. See, my straight line is somewhat shaking, don't bother, it is a straight line only. x4, this is the next approximate root x4. This is regular falsy method. RFM stands for regular falsy method. But in secant method, what is this? In secant method, just I'm telling the concept. In secant method, initial roots are what? Initial roots are x0 x1. Okay, x0 comma x1. The next root x2 is, what is the formula? x1 minus, okay, as per the formula, x2 minus x1 by f2 minus f1 into f2 into f2. This is the formula. Okay, next one, the next root x3 is, what is the formula? Directly x3 depends on its previous values. x2 is depends on x2 x1, that's it, x2 and x1. So x3 equal to x2 minus x2, just wait, this is x0 x1, this is x2, this is x1, this is x1 minus x0, f1 minus f0 into f1. Okay, and this formula is x3 equal to x2 minus x1 by f2 minus f1 into f1 into f2. This is the formula, and so on, like this. But coming to in secant regular falsy method, at each iteration after getting x2 value, to decide x3 I have to locate the interval again by using intermediate value theorem. That is the difference. If still any doubt is there, this will be clear when we will do the problems. Okay, let us consider one example. Use secant method and regular falsy method, RFM regular falsy method, to determine root of the equation cosine x minus x into e power x equal to 0. Solution. Now here what is the equation f of x, or expression for f of x is cosine x minus x into e power x. First locate the interval by using intermediate value theorem. So take any choice of x values, but you should take x in terms of radians. Why? Because trigonometric function is there. Cosine 0 minus 0, this is 1, and f of 1, let me take f of 1, this is cosine 1 minus e power 1, this is minus 2.178 less than 0, this is greater than 0. Since f of 0 is negative, positive, and f of 1 is negative, the product is less than 0. Since this one, by using intermediate value theorem, by capital intermediate value theorem, the root xi belongs to what interval? 0 comma 1. Xi belongs to what interval? 0 comma 1. Now here let me consider secant method. First one, secant method. In every method, in secant method or regular falsy method, we need two initial approximations. Let the two initial approximation be, let the two initial approximations be, one is x0 equal to 0, another one x1 equal to 1. These two, whatever the starting values are there, let me consider those two as initial approximations. Okay, now what is the in secant method? What is the formula? Secant method formula is, secant method iterative formula is, xk plus 1 equal to xk minus xk plus 1 equal to xk minus xk minus 1 by fk minus 1 is multiplied by fk. This is the secant method iterative formula. Therefore, what is x2 value? x0, x1 already it is there. x2 value x1 minus x0 by f1 minus f0 multiplied by f1. This equal to, what is this value? x1 value is what? 1 minus 0 by, what is this value? fk. Fk means what? f1. What is f1? f of 1, this value, that is minus 2.178 minus f0 value 1. This total multiplied by f1. f1 is what? Minus 2.71178, and this entire value is 0.31466. Similarly, the next approximate root is x3 directly. No need to locate the interval in secant method. That is the main difference between secant method and regular false method. Directly apply this formula in regular false method. X3 equal to what? X2 minus x1 by f2 minus f1. This is entirely multiplied by f2. Okay, so let me consider first f1 value. Already I know f2 is nothing but what? F of x2. F2 is nothing but what? F of x2. F of x2 means what? F of 0.31466. That is equal to cos 0.31466 minus 0.31466 into e to the power of 0.31466. That entire value is 0.51987. Okay, therefore what is x3 becomes? x3 value is x2 value 0.31466 minus x2 minus x1 by f2 value 0.51987, f2 minus f1 f1 value is what? Minus 2.178. This entire multiplied by f2 value 0.51987. so this x3 value is 0.44672. okay, then what is f of x3? F of x3 means f3 value. This is f of 0.44672. This is cosine 0.44672 minus 0.44672 into e to the power of the same value 672, and this f of x3 value is 0.20354. Now x4 is, what is x4? Secant method formula: x3 minus x2 by f3 minus f2, this entire multiplied by f3. So if I substitute every value, x4 value is 0.531705H. okay, this is secant method. Okay, now regular false method. Now you will see what is the main difference between secant method and regular false method. Here let the two initial approximate roots be x0 equal to 0, x1 equal to 1. x0 equal to 0, x1 equal to 1. Then what is f0? Already we have calculated f0 value 1, and f1 value is what? Minus 2.178. Okay, next one, what is f2 formula? Now RFM, regular false method formula is, or iterative formula is, same formula, no change in the formula. xk plus 1 equal to xk minus xk minus 1 by fk minus 1 multiplied by fk. Same formula. See what is the change here. Now what is x2 value? Now x1 minus x0 by f1 minus f0 multiplied by f1. The value is same, the first value is same in secant method and regular false method. What is 31466? Now find f of x2. F of x2 means f of 0.31466. Already we calculated this. once again 31466 minus 0.31466 e to the power of 0.31466. Okay, and this value is what we got already, 51987. This is f of x2, it is positive. Now here f of x2 is positive, and which is negative in the first stage, f of 1 value is negative, minus 2.178, that is negative. This is important, main important. In regular falsy method we have to locate the interval at each stage. Here f of x2 is positive and f of 1 is negative, therefore the next root lies between what is this is f of x2 means x2 point is what, 0.31, lies between what, 0.31466 comma 1, and you treat this interval as the new one. What is this, xk minus 1 comma xk. You treat this interval, this is very very important point. Once again, after calculating the first root, again you have to locate the interval. This is f of x1, one can say. Okay, this value is what, 0.31466x2, and this value is what, 1. Okay, so the next root lies between, these two are having opposite signs, lies between 0.31466 comma 1, and you treat this interval as xk minus 1 comma xk. Then the next root is, what is that, xk plus 1 formula, xk minus 1 by fk minus 1, this entire multiplied by fk, isn't it right? Otherwise this is okay. So what is the next root actually, x3 equal to, and one more point to make it easy for the computation. See, this next root belongs to what, 0.316 comma 42. This is our new interval, xk minus 1 comma xk. You treat this interval as now new one. What is this interval next? This interval is already x0 x1 is over, so you treat this interval as x1 x2. You treat this interval as x1 x2. Okay, already x0 x1 is over in the first stage. x0 x1 is over in the first stage. Now the new interval is what, x1 x2. Therefore what is x3 formula, x2 minus x1 by f2 minus f1, this multiplied by f2. Now you know all the values. What is x2 value, 0.31466 minus 0.31466 minus x1, that value is 1, by f2 value is already here, right? f2 value is what, 0.51987 minus f1 value is what, minus 2.178. This entire multiplied by f2. What is that f2, 0.51987. Now you will get x3 as 0.44672. Now calculate f of x3 value to again locate the interval. F of x3 means, what is this? This is, I will write like this, cos x3 into e to the power of x3. Substitute x3 value, then you will get 0.20354, means positive. So the next root x4 belongs to which interval? This is positive, and which is negative in the previous one? F of x1 is negative, f of 1 is negative. Now let me write clearly. F of x3, what is that x3? 0.203, sorry, f of x3, what is that x3? 0.44672 is positive, and which is negative in the previous interval? F of 1 is negative. The next root x4 belongs to what interval now? what interval? This is 0.44672 comma 1, and compare this interval with what? This is now already which interval, what intervals are over? x0, x1 is over, x1, x2 is over, so this take this as x2, x3, and x4 equal to, what is the formula? x3 minus x2 by f3 minus f2 multiplied by f3. So what is x3? Already I had x3. What is that? 0.44672 minus 0.44672 minus, what is x2 value? Already I got x2 value as 0.31466 whole by f3 value. What is f3? 0.20354 minus f2 value. What is f2 value? 0.51987. This entire multiplied by f3, 0.20354. So x4 value is finally 49401. Okay, this is regular falsy method. So what is the main difference? In regular falsy method, in RFM, we have to locate the interval. We have to locate the interval at each iteration. Whereas in secant method we have to apply the formula directly without locating the interval. This is the problem. I think it is clear. If any doubts, you can raise the questions.